All right. This is very similar to the last one. And it's how to start the use of the cluster using a tool called OGRT. So the important question is, who am I? I'm Georg. I work as a systems engineer at IMBA. And an important question will be how this came to be. So some history. I've been working there for 1.5 years now, and we got this cluster handed to us, right? So we had a problem because we were told it has a very diverse workflow. We're doing next generation sequencing, electron microscopy, reconstruction, video compression, and some other stuff, but who knows? So, well, who does? So we figured out, well, we could ask the users, right? And then we asked the users and we got an answer, yeah, well, we have this script and it's a pipeline and it's called something like this. And then we had the option of go through the script and check all the programs and all the module loads, and there is hard-coded paths and everything. So as much as we like manual labor, this was not an option. That made us a bit unhappy. Then we heard this in the last talk. Module loads do not actually mean that the programs get used. So what we see a lot is, this is a sample.profile, so that's the real one. So the user has in his .profile all these module loads. He does not use the programs, but your hooks will get triggered, and which means a load is not used, so that also sucks. And then there was Excel. When we started this, it was early 2014. Well, before that, 2000.
Well, I announced it before, but
oh no, end of 2014, I think.
Well, yeah.
So, which was cool because then we thought, well, somebody had the same problem, which is always nice. It does tracking of the compilation, so at build time, which was pretty cool. It did this watermarking of binaries in shared object, and it was, what has been done there was quite amazing. So, but we had some problems with Excel back then, and I think parts of 2015.
Yeah, yeah, it's really, and it hasn't been publicly available even in all of 15.
Right. So there has been some parallel development. You will see very huge similarities, but some differences, like same but different. But Excel, I think, because it comes from tech and you're running big MPH, it's not designed to track everything, and we want to catch everything. Because what we see a lot on our cluster is NGS pipelines, which are a bash script that calls AWK, that calls SAT, that calls cut, that calls some other programs. Some of them the user has in his home directory, so that kind of stuff. So then we thought, what do we actually want? What would we need from a tool that tracks usage of programs on a cluster? So we wanted to track everything, absolutely everything. So if Robert is the Google approach, we're the NSA approach, kind of. We wanted to track every shared object the program loads, because that's actually quite important, for us at least. We wanted also to be able to embed a signature, to be able to tell what program exactly was running. And we wanted to do it without the launcher, be lightweight and transparent, and we wanted to process that in real time, or near real time. So again, LD preload, which means you tell the loader before all the other shared objects, take this one, and then if you combine this with the GCC constructor, which is basically, not basically, it is the same as this init array and Fini array, then you get the same effect. So once your shared object gets loaded, you're in the program's address space, which is very nice because then you can do some magic, and so you don't need the launcher. So how do we track the shared objects? That was quite an interesting one. The loader has a function called dliterate_pheader, which finds out at runtime, so your program is running, you're in the address space, you iterate and see what shared objects are loaded, and then you're set. So we could put a checkbox on that one, and then there was this other question, how do you read a signature? So what this iterate p-header program does, when your ELF gets loaded into memory, the sections on this get to be program headers somehow. What we can do is iterate everything that's been loaded into memory, so the shared objects, and read the signature out of memory. So which means when we do this, we don't need to go to disk to read the signature, which makes this pretty quick. How do we get the signature in? We link a section into the ELF. So basically you just say at link time there is an object and I want to link it in. You may have seen this, GCC does it the same way, and the API compatibility and the build ID is in your executable. That's done exactly this way, and OGRT uses the same nodes, which are, by the way, pretty sparsely documented, but if you read the source code of build utils, everything's pretty clear. So the signature is, I've talked a lot about it now, it's very, very similar to Exalt. You can link it into, link an object file into the ELF, gets this node section, it embeds an UID. The only drawback you get if you do it like this, because we're doing reading in memory, you cannot do this with an existing program. Because if you do that, if you patch in a section in an existing program, it does not get loaded into memory. So why do we need the signature? The same path does not mean it's the same executable, especially if you have programs lying in the user's home, because the user will do several compilations of the same problem. We wanted to discern between them. Also, it's a protection from yourself, I guess, because if you recompile a module, you will know it this way. Because I mean, you shouldn't do this, but if you do, you'll catch it. What you catch with this is what we saw at the beginning. If you have this in your doc profile, these two programs actually shadow each other. So parts of the one program override parts of the other. You'll catch this. And this we see a lot. By the way, if there are any questions, just ask them right away. So we tested this, of course. Are we lightweight? Yes, we are, I think, because we're doing everything in memory. We're not, well, there's a small catch. What we do is we resolve the pass of the binaries we're loading. So we're walking, if there are symlinks, we're walking the file system, but we did not test it, but I think it should be able to do this in memory because you're actually loading the program. So the OS had to do the walking before, so it should be in cache somewhere. But potentially, who knows what the kernel does. So, are we transparent? Well, we ran this for a month and our users didn't notice, so I guess yes. So a quick recap, we did all of this and then we wanted to process the data near real time because it would be nice to give the users a dashboard where you have your job and then they see their information. So what we did, and this is where it gets a bit different from Exalt. libOGRT is the preload library which you load into the process. Then you have the server, which the thinking behind this was, if you want to do processing, you don't do it into the preload library because then you're doing it in every process. You do it in the server, so you do aggregations and data processing and whatever, and then you push it into the data store. In the moment we support Elasticsearch, Splunk, and file output. I have to say file output I would only use for debugging. It's very slow because the implementation is a bit fishy. But between libOGRT.so and the server, we're using protobuf. So if you want to write your own server, you're totally fine to do that. So I would show you them now if you're interested. Why is everybody so quiet?
Because we are impressed.
Yes.
We're impressed that the presentation is working even when you're using Linux.
Well, I'm impressed too.
So are you wrapping the linker as well, or do you just need to give it, tell it, make a little bit of space in there for me when you link it?
When you link it, it's just add this section to the
So,
other.
so you're doing what I'm doing in terms of wrapping the linker? You're hijacking the linker?
Well, we didn't, I'm doing it manually now, so we
Oh.
did not hijack it. I can show you. Let me show you. Is this readable for you?
Make it a tad bit bigger.
Yeah, little bigger.
Or put bold fonts.
How do
It's
One
another
more.
step and it's okay.
Okay, I'll give it.
Yeah, that's good.
So now I don't see it. So I prepared some stuff. This is the program where you can see the signatures. So I prepared an example program here, which you can show the signature as it is on disk. And then you see, and then you see this is a section in the ELF where you have the UID, you have the version of the signature, because if we change it, it would be nice to have a version. What you also can do, because we're reusing what GCC does, you can use readelf, which is in binutils, and can have this shown here. So you see the ABI compatibility, then you have OGRT, and then you have the build ID, which comes from the linker. So we're reusing what the GNU guys are doing and basically using this as a container for a custom format. So how do we link this in? This is the same as with Exalt because the mechanism is the same. So we generate the signature and then we link in a so and an example. So the programs, they display hello world. So let's see. Don't do this in real life. So this is what you see. To link them in, if we want to make a shared object, we want to call, and we want to call it lib example.so. We want to use this one, and then, so now we have our example thingy, then we can show the signature in this one, which should show nothing, right? And it does. So if we now generate a signature to, I don't know, sig, and then link it again, then you see it has been watermarked. So this is the watermarking stuff. But to show how this actually works in production, we first, I guess you want to bigger again. What's the shortcut for that on the keyboard?
Control+.
Mm-hmm. No. So we have the server. Well, that's a problem because there is no Elasticsearch. So I guess we should start that first.
Did it start?
Yep. we have now is, there is a debug endpoint on port 8080, so you can see what the server, yes, exactly, what the server does. So you get stats of how many invocations it has processed. Then you see there, we have an Elasticsearch output, and we have an output for debugging into temp. Here it shows you the rate of accepts and outputs and blah blah blah, which in this case is 0 because we didn't do anything yet. So to actually enable this, we need to do a few things. So the client is the thing that does the preloading. So we set the preload to the current working directory. And I'll have no tab completion. Exactly. Maybe I should export that now. So now we're preloading OGRT into everything. So if we do, there are a few, well, because there's no other way to interact with the shared object, you're using environment variables to control it, so there would be yes. The loader gives very nice error messages. So you see, let's do it again. Because we have it preloaded, we can say it shows the debug info. We set net host and port at compilation time, which makes it that the user can't modify it. You see env job ID is which variable it uses to resolve job ID. So in this case it's just job ID. Which name does the section have, and the elf node type, which is internal stuff. So nothing happens yet, right? Because we're not doing anything. To enable it, we should do, we're gonna set a job ID, which is 1. Just because we're in a job now, we're executing on the cluster, and then we say we want this to be active. And then you see, oh, something's happening. But because if you're running on the cluster, you want this to be very silent. And then it's silent.
What's the joke? He's using German.
Yeah, I know that, but what is this?
I know what the German says, but
This is what submarines do when they go silent.
Exactly. So we are a submarine right now.
is it submerged or
Yeah.
It's silent mode.
silent?
I'm sorry, it's not. So what we do now is, because we have our Elasticsearch in the background here, and this looks very bad. And then you see that we actually executed ls.
Can you make it bigger?
Can you make it bigger? You can't see anything.
You're obsessed with size.
Size doesn't matter.
You see this scale? That's very. So that's what we do in Elasticsearch, because we did some ls before. In this very simple example, you see the job ID, which was 1, the bin path. We have no signature because ls is in the system, so you have none. And if you open this here, you also see which shared objects ls loads, which is actually quite a lot. And if this shared object would have a signature, you would see that too. So, to show the other example, so we have our example program, right? And now we run it. So we get this hello output. And if we go back here now, and we should turn auto refresh on, because then we actually, and then we see it's there. So we ran the example, it has this signature, and if we open it, we see that here it dotted live example.so, and this has been watermarked also. We've been running this in production, not with Elasticsearch as a backend, but with Splunk, which is kind of the same thing, but more enterprisey. We got around 1 million events per day, and that worked reasonably fine. Well, it worked fine because nobody noticed. I think there was a question before, what do the users think? If you tell them that they're monitoring their every command, they don't expect that.
No. Well, some users don't even expect you to be able to access their account.
Yes, but
If you just tell me where your script is and I'll look at it.
it's actually
what do
pretty
you
great
mean?
because we didn't do much in analytics, but we saw that users are using a program. I don't know if anybody heard about it, AA. Yeah, exactly. There's very arcane stuff going on clusters. So
We should remind me that I should rename my Bitcoin mining program to be called something else.
This is I was just saying to him, right? Most of the clusters they use just to mine Bitcoin.
You catched it.
So, some outlook. Some testing would be nice. The code is quite simple, but I didn't write any tests. Don't ever do that, that's bad. That's missing. Documentation. There is, in the GitHub repository, a README which describes this. Probably there could be more.
Yeah, you think?
But the code is documented. It has headers and everything. It would be interesting. You could be compatible to Exalt, at least for the runtime tracking, if you take as an output from a SQL database, you could gather the same information as Exalt if you want that. So you could converge these two tools. And, which is interesting, which should be possible, which is very possibly symbol level tracking. You can, the loader has hooks, RT&D audit, and then you would be able to hook which symbols it resolves, which also tells you, because it's doing this lazily, what symbols get used in the libraries that the users are using. Which, well, personally, it would be nice to do because it's kind of cool, right? I'm not sure.
I didn't talk about that, but that's actually, we do something similar. We do it differently. The way we do it, since we got the linker, we link the code once without any of the libraries specified from LMOD. So FFTW, Boost, whatever, are not linked in. We get all the error message that says, hey, these symbols were failed to resolve, collect that data and stick it in the database, and then relink your code.
Well, this is, then you can.
But your way, I think, is really slick.
Oh, this Todd Gamblin told me this trick because they have this thing called Spindle, which distributes shared objects over MPI. Pretty cool stuff. They're using this loader hooking. It's pretty great stuff. There is lots of other stuff that could be done, so we're open for PRs. That's it. Any questions?
A question on IRC. So I think it's Adam. He's asking. So the way you watermark the binaries and all that stuff, it's kind of manual, and he's thinking about what if someone else wants to do, what if another side wants to do the same kind of analysis on the same kind of program, so you have to make sure that everything's exactly the same watermarking, same everything.
Why? You can have extra watermarking. You can do as many times as you want.
Well, that's you can use Exalt and OGRT at the same time. That's totally fine. You can teach.
To actually work?
Sure.
Of course.
It's just two separate ones. Okay.
You can have, and watermark is an elf section, you can have as many as you want.
I mean, as long as you don't name it the same as me or him,
Yeah, it doesn't get any terms.
I
Well,
mean,
if you look very closely into the OGRT repository, there is this, which wraps the linker, so try it out. But we didn't test this, but this would hook the linker. It's just, I mean, you replace LD and then you just push
the only,
it.
yeah, you gotta, it's tricky to find, you gotta go find the one that you really need to call.
Yeah.
Because your LD is in the map, you know, you can't just use the standard path trick. Anyway,
So the question is actually, if you watermark something,
Yes.
is it possible that it in some way it affects the runtime?
No.
no, it's just data.
No.
Well,
Because no.
it has to, for those 100 bytes that are there, it'll take that much longer to load the program.
Look, what we're doing in the end.
But also, let's say for random seeds, if you have a hard-coded random seed or any of that stuff.
This is not an executable part
Just-
of the
just-
program.
Now, the one thing you cannot do.
Your execution never sees anything of that.
But the binary is a little bit bigger.
Look,
Yes, and in
And
fact,
actually that may be enough to affect the runtime.
yes, it could.
Depending on what you're doing.
Yeah, it could, it could. The other thing you cannot do is you cannot use either his tool or my tool to build GCC.
You can't watermark GCC?
No,
Why not?
because the way it builds it, the third and fourth stage, is it compiles it once and it does a binary, it does a diff, compare on the results.
Binary compare?
It does a binary, bit for bit compare.
So you just have to watermark always.
But it changes. I have the date, I have a UUID. It changes every time. Not gonna be the same bits.
I use the same
Glad you just reach in there and turn that.
And the same date.
Yeah. Well, you could do that, right? You could.
But the thing is, what we're using has been done before, and we use it every day. So this is a program that has nothing done to it, and it has one of these nodes. So that's GCC, and that's quite recent, so it does not influence the program in any way. If you do it, if you would want to take an elf that's already existing and push a section into there could be problems, but you're not doing that. I tried, it didn't, well, it does work. The problem is when you do that, you cannot load the section into memory because it's not one contiguous block. And then you run into problems, so.
So you're storing a lot of data. By far, what kind of insight did you get from all of this? So what's the interesting stuff you get?
Well, we learned that there is AA, and we learned that the users do lots of stuff that you just don't see.
It's like millions of invocations of graph and stuff like that.
On our cluster, like AWK is a shining star of HPC.
Yeah, it's EWK graph, this is the most executed binary.
Seriously,
You see, this is stuff that you build yourself, and you see stuff that the users build them.
yeah, there is also stuff that the users use and they never tell you, and they actually think that they're using your stuff, but they're not. And well,
So is this like,
what
I mean, if you use this within like EasyBuild or something, right, it would be fairly straightforward, right, to just build this in, so you can have all your own stuff signatured, and then the user themselves would have to do it by hand, right? Potentially, I mean, if they do the signature piece.
Oh no, it's just I didn't come around to hook the linker yet. If you hook the linker, you're
If you
totally
hook the
fine.
link, yeah, if you hook the linker on them,
You can also make your own linker if you really want.
Replace the actual link.
What the thing is,
Well, you can do what I'm doing, these wraps.
But normally, yes.
Yeah, but that's what it
well, the assumption is if a user goes to your cluster, he or she will use a compiler that's already on the system. Because if your user compiles his own compiler, he's cool. Like, let him do his shit. If
Yeah, but
a
there's
user-
only one LD.
Yeah.
But you can make your own.
No, well,
Yeah, you
those
can make your own
LEDs.
LD, but if you use the path, now, the coolest thing I'm thinking is you could do, one cool thing you could do is you could have LD preload,
Yes.
set LD preload with your magic function. Recognize that a program called LD was being called.
Really.
Well, no, and then do whatever you want to do in the init function.
Yeah.
Call what you want to call, and then and then don't do anything the first time you call it, because you don't ever want to call the real linker. You want to call your wrapper, and then the true one, and you could do it.
Stuff like this, because OGRT could do this, and I took it out. It used to hook exec and DL and DL open and some stuff. I took it out because I wanted it slimmer, less. This is very possible. It's just quite invasive, and you run into, if you're hooking functions in programs, you run into problems along the line. I'm pretty sure of that. Which maybe you don't even see it, because you would only see it if the user opens a ticket with you, and they. But to the question before, which insights would you get? Our problem was, we have a cluster, we got this very diverse workload. Okay, so this cluster is dying because it's getting old and everything gets old, even computers. So we need to buy a new one. What machine do we buy? Because there is everything running on there. There is MPI, there is non-MPI, there is high throughput, IO heavy, CPU heavy, everything. So what do you do? How do you build the machine? This is what we wrote this for.
Also, there's a nice use case for EasyBuild, because if you come to a machine that didn't have EasyBuild before, so it had a hand-rolled software stack, and you want to start with EasyBuild, where do you start? What do you do first?
Other stuff is like AWK. It's actually like AWK. If the
Obviously,
user
you need
uses,
to rewrite AWK. Version of AWK.
yeah, well, there have been lots of rewrites. If a user uses a system AWK, I want to know.
Well, I mean, yeah.
Because it makes a difference. If you expect him to use one from the module, and he uses a system one, and your module is mock, and
I see.
yeah.
More recent and heavily optimized.
No, I see, yes.
I think there is lots of stuff we just don't see, and the users don't come to us if they're for lots of problems.
And they have no clue where they're spending most of their time anyway.
Yeah.
I mean, they may think, hey, AWK is calling, but no problem. Yeah.
All right. Try it. It's actually quite simple to get this deployed. And you can do Elasticsearch in Docker, because Docker is very quick and everything's nice.